All right, so if you missed today, which is Tuesday 8/3, this is what we did, okay? So we are going to be finding x and y intercepts in different ways. So to find the x-intercepts, we're going to first focus on just looking at this graph, all right? So you can't really see, but we want to know where our graph is crossing both of our axes. So this is our y-axis, right, going up and down, and then we have our x-axis that runs left to right. So we want to see where is our function, oh, went off the line, but that's okay. Where is our function hitting our axes is the correct term. So you can't really see the numbers unless you look really, really close, but we do see that our x-intercepts, where our function crosses our x-axis, crosses at 1, 2, and in the other direction crosses at 1, -2. Okay, so this was 2 and this was -2. And then our y-intercept, just looking at the graph, we go down to -2, -3, -4. Okay, so not too bad, just looking at the graph, looking at where it crosses our axes. So if we're not given a graph and we want to find the x-intercepts of our function, we are going to let y equal 0. Okay, so we don't want anything to do with y. When y equals 0, we're going to be able to find our x-intercepts, right? Because we go, it makes sense looking at our picture. We go over our x value, but we don't go anywhere up and down. So y is 0. That's how we're going to solve for x, or our x-intercepts, okay? And then just the opposite, to find our y-intercepts, we don't want anything to do with x, so we're letting x equal 0. And then we're going to solve for y. Okay, so let's do an example. Looking at this function right here, let's start with finding our x-intercept. So going back here, when we want to find our x-intercept, we go ahead and solve for x by plugging 0 in for y. So we're going to have 3x plus 2 times 0 equals 7. Okay, just plugged our 0 in for y. So we're going to have 3x plus 0, right? Anything times 0 is 0 equals 7. That can just go away. And to solve for x, we're going to go ahead and divide both sides by 3. So our x-intercept is 7 over 3. And to write it as an ordered pair, we have x comma y, right? So we have 7/3 comma 0. That is our x-intercept. On the other hand, when we want to find our y-intercept, we're going to go ahead and plug 0 in for x when we want our y-intercept. So we're going to have our ordered pair is going to look like 0 for x, comma, whatever we get for y. Okay, so go ahead and plug 0 in for x. Leave everything else the same. This is just 0, right? 3 times 0 is 0, so that just goes away. We have 2y equals 7. Solve for y. We divide both sides by 2. So we get y equals 7 divided by 2. So just filling it into our ordered pair, our y-intercept is 0, 7 halves. So, continuing, let's do another example. If we want to find our x-intercept, given this function, we're going to go ahead and plug 0 in for y. Okay, so we're going to have our number, our x value, comma, 0 for y as our ordered pair when we're done. So we have 0 for y here equals negative x squared plus 5. I want this to be positive. I feel like it would just make our lives easier, so I go ahead and always add exponents to the other side to make them positive. So we have x squared equals 5. We want to get rid of that square, so we're going to do the inverse. Square root, what we do to one side, we have to do to the other, so this goes away, and we are left with x equals plus or minus. Don't forget that whenever we take a square root of a number, we get plus or minus that number. So our x-intercept is positive square root 5 or negative square root 5, comma 0. For our y-intercept, we're going to go ahead and do the opposite. So we're going to plug 0 in for x. We want nothing to do with x. So we get y equals negative 0 squared plus 5. This goes away, it's just 0, so we get y equals 5. And our ordered pair is going to look like 0, comma 5. So what does this even mean, right? So let's go back to thinking about our graph. If I asked you guys to graph this, you don't have to do anything crazy, okay? Just a simple x, y coordinate plane, all right? And our y-intercept is at 0, 1, 2, 3, 4, 5 here. And our x-intercepts are at, this is gonna be a super, I'm just gonna put square root 5 here and negative square root 5 here. Okay, it's like somewhere in between 2 and 3, but we have coordinates there, so we just connect the dots, and that is what our graph would end up looking like. Okay, so that is a really rough estimate of what this function looks like graphed. All right, third example. When we want to solve for our x-intercept, we plug 0 in for y. We get absolute value of 3x minus 9. Okay, absolute value equal to a number. Usually we would set it equal to plus and minus that number, but since this is just 0, we can get rid of that absolute value. Okay, add 9 over and divide by 3. So we get 3 equals x. Our ordered pair would be 3, comma 0. Our y-intercept, we want to go ahead and plug 0 in for x. So we get absolute value of 3 times 0 minus 9. Okay, anything times 0 is 0. We get the absolute value of negative 9. Absolute value, distance from 0, negative 9 away from 0 is 9. Absolute values are always going to be positive, and our ordered pair is going to look like 0, comma 9. All right, so for a square root example, same steps. We're going to plug 0 in for y when we are looking for our x-intercept. Equals square root of x minus 5. Sorry. I thought I wrote something wrong. I didn't. Square both sides to get rid of that square root. Okay, 0 squared is going to be 0, and we get x minus 5. Add 5 to both sides, right, to get rid of that, get x by itself. So our x-intercept is going to look like 5, comma 0. Our y-intercept, we plug 0 in for x. We get y equals the square root of negative 5. Can we solve this? If we square both sides to get rid of the square root here, we're going to have a y squared equals 5. So then to get a y-intercept, we're going to have to take the square root of y squared, which would give a square root of negative 5. So we can't get rid of this square root, and it is square root of a negative, which means there are imaginary solutions there. You guys don't have to worry about that. We're just going to write no solution. You cannot have a square root of a negative number. Okay? So there is no y-intercept. No y-int. Okay? Okay, so the last example, tried to go through this a little bit quick for you guys. X-intercept, once again, what do? Plug 0 in for y. We have negative absolute value of x plus 7 plus 3. Okay, we want to get this absolute value by itself, so I'm going to subtract 3 over to get this by itself. And, oops, this should be negative. Since this is negative and this is negative, we can think about multiplying both of these by -1 to get rid of these negatives. So both of them, since they're negative, can both become positive. Pretend like we just multiplied both sides by -1. Okay, absolute value equal to a number is going to be equaled to plus or minus that number. So we have the absolute value of x plus 7 equaling 3, and, oh, I'm going to go down here, the absolute value of x plus 7 equaling -3. Okay, absolute value is the distance from 0. 3 and -3 are both the same distance from 0. Okay, so we're going to go ahead and subtract 7 over to this side to get us -4, and we would subtract it over to this side here to get us -10. So our x-intercept here is -10, 0, and our x-intercept here is -4, 0. So we have two x-intercepts. For our y-intercept, we make x equal to 0, so we have 0 plus 7 equaling 3, okay? The absolute value of 7, 0 plus 7 is just 7. Absolute value of 7 is 7. So we have y equaling -7 plus 3, which means y equals -4. So we have a y-intercept at 0, -4. Here's your homework, posted to Canvas. Please turn it in on time. Thank you.